we are here to talk about backups this afternoon. Title of the talk, Lock, Stock, and Backups, Data Guaranteed. We're going to go through the importance of having backups, some of the tools we use on a day-to-day basis with Percona services, and also some of the best practices that we would recommend. So for those who haven't met me before, my name's Andrew. I work with Percona in the services delivery team. My colleague Jervin. We've both been around the services delivery departments at Percona, so we've seen quite a vast array of implementations of backups through consulting, support, managed services. And so we're here to deliver our interpretation of best practices, both some theory, but largely preaching what we practice and vice versa. So the agenda of the 50-minute talk will shape up loosely like this. We'll have a quick introduction into backup and recovery as a bit of a primer. We'll talk about some of the tools, so binary log backups, logical backups, physical backups, storage-based ones, backups in the cloud, some of the services that are available, crucial monitoring and testing, the recovery phases, and then encryption and security, because security is an ever-growing hot topic, especially with data and the way we use it today. So, first and foremost, the introduction, the simple question, why do we take backups? I hope that you'll all agree with me that it's an absolute necessity. I'm sure many of us come from organizations that where data is pivotal to the success or failure to making money or not in the moment. So it's crucial that we leverage backups as an insurance policy. We don't necessarily want to use backups that often in a disaster recovery context, but we need backups in our infrastructure to ensure that we have that portion of business continuity and disaster recovery filled. The last thing we want to do is have an incident such as GitLab's had recently. So therefore, a good backup implementation is, we think, modeled around some core concepts. Some of them come from the business. So business questions cause us to identify and to work around some constraints. So RTO, or recovery time objective, and RPO, recovery point objective, which are loosely how much time can I be down, how much time can I be unavailable for, and how much data can I lose. So when we talk to our C-level executives, of course, they don't want to lose any data and they want to be up 100% of the time. And the smaller the gap between these two elements, the more expensive the disaster recovery solution. So I think, we need to find a happy medium somewhere. It will largely vary depending on what you use your data for and what your business case is. But it's an important thing to hold in place. It's not just acceptable to just select a technology and roll with it. There are other things to consider. So how long do I need to hold on to backups is a question that will generally be driven by the business as well. So you may be bound by some law that you need to retain backups for X amount of time. And how does that factor into your tooling and infrastructure decisions? And the actual tools that we can use for backups may vary depending on the answers to some of these questions. So the backups in terms of technologies and procedures we'll look into today: binary log backups, logical backups using MyDumper, physical backups using ExtraBackup from Percona, and file system snapshots or storage level snapshots. I don't know, do I keep getting louder and quieter as I turn my head? Okay, binary log backups. They're not a backup solution by themselves. They are complementary of other backup solutions, but what they provide is a point-in-time recovery. This is a solution that we work with very closely in managed services because to provide the granularity of point-in-time recovery for our clients is invariably critical for surviving disaster recovery scenarios. We opt to use MySQL binlog, the client tool that's available bundled with Percona Server, MySQL Server, MariaDB, and that allows us to stream binary log events from our writing nodes. The version in which we use is at minimum 5.6 for these capabilities. But of course, you're not bound to using this technique. You can simply copy the files off if you so wish to. What this provides us is the ability to connect to an instance as a client and stream the events off onto another file system, and then take the next steps. So in terms of pros and cons with this technique, there's not a lot to discuss in this. It's does it fit your use case, yes or no? I like to think that 99% of the time we would elect to back up our binary logs. It's not just a point-in-time recovery mechanism. There are other use cases for this method. So the strongest reason for backing this up is point-in-time recovery. So as we are streaming these off, if we do it remotely, we have free off-server backups. You don't have to think too much about it thereafter. But also, if there is some auditing requirements, if you need to pinpoint when a change was made, you do have the binary logs. Although it can be needle in a haystack, but at least you have record of event. Reasons why you might not take it as an opportunity for backups is if you're potentially working with something like a storage snapshot, and you can afford to do this at regular intervals. So it's not necessary, perhaps, as a business justification to maintain this extra infrastructure. So for example, I hope it's readable. Very simply, MySQL binlog can be used with these. This is a single line example of a MySQL binlog command that will connect to a remote server of an address, and it will continuously stream the events off to its destined file system location, and there you can do whatever next steps you need to. So compression, encryption, whatever it is that you need to do. We'll move on. Logical backups with MyDumper. Anybody using MyDumper here? Yeah, cool. So MyDumper has been described in the past as MySQL dump on steroids. It's a parallel logical dumping tool. So what you get out of a MyDumper run is instructions for MySQL to rebuild your data set. So it's got quite a few modern day use case features. It's an open source and community maintained project, but we have a colleague at Percona who injects our feature requests quite rapidly into the project. So he's a major contributor. So some of the more recent changes have been use cases for Percona clients. So it's evolving based on requirement rather than a company thinking of features and feature creeping. So things like working seamlessly with our Percona server backup blocks, which is an alternative locking mechanism that will be a bit more permissive with certain engines. We can be elective or exclusive with the objects we want to back up. So if we want to take a partial backup, it's very easy with MyDumper. We can provide regex to include or exclude tables or schemas. We're able to kill long-running statements that might get in the way of any flushing or locking that we want to do. So that's, again, another feature that was born out of necessity for some of our clients. We can compress on the wire, so it's built into the tool. We don't need to do this after the backup is completed. And there are various levels of lock reduction built in as well. So if we want strong consistent, we might have to put up with some flush tables and read locking, but there's opportunity to lessen the load if we don't necessarily need that strong consistency. Recent releases have been able to replicate some of the missing features that we still needed MySQL dump for, such as schema backups. So things like store procedures, triggers, events. We were relying on MySQL dump to gather that for us. But in, I think, the 0.9 releases, we were able to gather them in a single tool, which is nice and convenient. Pros and cons with MyDumper. I mean, with most tools, we select them and we have trade-offs. But one of the major drawbacks with MyDumper is that there's no streaming to stand it out. So any of the manipulation of the data that we are pulling from the database has to be done after. So the big one's encryption. If you want to take your data and move it to, a backup server or shared storage or something, you want to encrypt that, and we need to elongate the backup procedure by adding some encryption. And I have a short example. As I said, we drag the data out with a logical result. So in fact, it's instructions on how to create the schema and then all the data. But it's all done in plain text. So we have the opportunity to be, investigative on that data set on the file system. So if we do need to see a row or how a table looked at the time of backup, it's easy to do such with tools like sed or grep or awk. It's nice and cheap to do that. Text is also highly compressible. So for very large data sets, if we pull our backups using MySQL or MyDumper, it compresses to a fantastic ratio, and that might facilitate moving these backups off server, maybe into the cloud. It would be unfair to overlook MySQL pump. However, experience at Percona with that is quite small. I don't think there's so many folks out there using it. Is anyone running MySQL pump in production? No? Okay, so MySQL pump is an Oracle-based tool. Well, no, Oracle MySQL tool. So again, Oracle identified that parallelism is a use case for modern instances, big data sets. We want it backed up fast. They managed to bring with MySQL pump some of the nice features from MySQL dump, which we don't yet have in MyDumper. Converting blobs to hex, for example, and being able to observe the progress of the backup. That's something that we can't do in MyDumper without external references. So watching the file system, watching process list, and seeing that the threads that are dumping the data are on this table or that table. MySQL pump offers more than one compression library. MyDumper just zlib. Two great tools. I think I would elect in production to have logical backups complementing any other solutions that I have for the simple use cases of being able to quickly restore partial pieces of data. I don't mean to do that. Another example, when we publish the slides, you'll be able to see a little more clearly if it's hard to read, but an example of how we would run a default backup with our managed services team. We are simply showing here, I think the most interesting thing is maybe kill long queries as inline options, remote addresses, so we can back up over TCP. We don't necessarily need to back up on the server we are backing up, which is beneficial for something like RDS if you want to the line near the bottom demonstrates how you might encrypt the result of a MyDumper backup. I'll hand you over to Jervin.
Okay, so the next type of tool that we commonly use inside Percona and our customers using physical backups is with ExtraBackup. ExtraBackup is an open source alternative to MySQL Enterprise Backup with all of the same features, although there are recent diversions. But ExtraBackup is fully equipped to take your workload in many common scenarios. It's consistent. It's designed for InnoDB workload, though it can work with minimum size of data with other storage engines. And it's highly configurable depending on what kind of traffic or what kind of workload you're getting on your servers. Some of the pros, it's typically faster because you're just copying from the file system, but it's not always the case because, if you're comparing per object backups against full backup from ExtraBackup, then that's not a fair comparison. But if you are basically backing up the full data set, then ExtraBackup will almost always be faster in most of the situations. It's also least intrusive when you're primarily InnoDB and you have a significant amount of concurrency going on or significant amount of writes at any given point in time during the backups. Per object backups are also possible, but it's not always the case. You have to look into why you need per object backups. If your ultimate target or your business use case is to just be able to recover or restore those specific objects, then you can use this, but it's not recommended on general use. Incremental backups, of course, compression and encryption features natively comes during the stream. Some of limitations that we have is, of course, it's Linux only, although you can probably compile it on BSD variants or Solaris variants, but you're mostly on your own. It occupies more disk space because you're basically copying your MySQL data directory, of course, excluding your binary logs or any error logs or slow logs that might have accumulated as well. And, of course, designed for InnoDB and data in workload. Here's a quick example with encryption from via GPG. TwinDB is actually using GPG encryption with their tool and service. What this brings compared to the native encryption that comes with ExtraBackup is that you can have better control of the encryption keys. If you are HIPAA compliant or PCI compliant, this might make a difference, especially if you got questions on, how do you take care of your keys. But the downside of this is that you don't have parallelizations during the stream. Even if you specify parallel or compressed threads or any number of the parallelization options with ExtraBackup, when it goes through GPG, it's basically serialized as well. So on a quick test on the same data set and on the same workload, I've got 22 minutes on GPG, and non-GPG, it's 8 minutes, right? But if you're using the native encryption that comes with the ExtraBackup, it takes advantage of the parallelization and the threads as well. So you might, your use cases may vary. Another good example, that we always see is when you're trying to rebuild your backups with a fresh snapshot coming from the master or from another slave, and you want to rebuild a number of multiple slaves with the same snapshot at one go. So you can use netcat and FIFO files for that. Thanks to Tumblr, I have been able to script this and just input some IPs, input some ports, and just do parallel SSH and start the backup, and you're done. Well, of course, without knowing all of those servers, if you're just first time, you can just put those scripts and be able to do that. Another common example is populating your Galera or PXE nodes without using the automatic SSD. In some situations, you want to have full control of that process when you're running Galera or Percona ExtraDB cluster, because when you try and automate you run into problems like locking or the workload. So you want to do it in a controlled fashion. So you can do that. The only difference here on the previous examples is using the Clara info option such that it takes into account the UUID and the sequence number available and makes it available on the ExtraBackup Clara info. More details on how to actually use this is available on the link if you're using Clara or PXC. So much for physical backups with ExtraBackup. Let's move on to file system snapshots. So why would you consider file system snapshots aside from MyDumper and bin logs and ExtraBackup? The most common use case is when you're trying to mix storage engines. We've seen customers running, hundreds of gigabytes in both InnoDB and TokuDB and having concurrent workload, and they're having problems to back those up. You can't just use MyDumper. You can't just use ExtraBackup for those because you'd basically stall on logs, or you'd basically stall on even on writes and I/O performance. So what makes sense, and what we've used in the past with Percona Cloud tool, which is now replaced with PMM, is actually using file system snapshots, more specifically with LVM backups. The problem is, or one other use case is you have really large data sets where taking backups with any of the other previous types that we've discussed is not really practical, right? We can see, or we will see later on in an example with Google Cloud Engine how efficient they've made it. And if you're in Google Cloud Engine, it just makes more sense than any other backup solutions that we discussed before. Yeah. So what is commonly available and what is commonly deployed? First one is LVM snapshots. The main problem with LVM snapshots is how it actually handles the snapshots when it's active, right? So it writes on both the primary file system and mirrors that to the snapshot. So when you do that, you're basically doubling down on the I/O, which basically, putting more pressure on your storage, and you don't want that on your production systems. So if you're trying to evaluate LVM snapshots, do that on a slave, which is non-critical, or do that on dedicated backup solutions or backup servers. One advantage, though, is you can easily write your own tools. And you just follow the same procedure out there, which is this is the most common outline on how you take file system snapshots, but there are minor differences that you will see later on. First one is flush tables. This is optional. If you have a large number of tables that are actively being used and on a high concurrency environment, you might want to do this to make sure that when you issue flush tables with read lock, it's much more faster because all of the tables have been flushed, and you will have minimal amount of tables that you need to flush again and block with read lock. The other one is sync your file system buffers to this, and then you can create your snapshot. Unlock tables, then you mount that snapshot, copy the files off of it, purge it, and then delete it when you're done copying. The other common file system snapshot that we encounter with our customers is ZFS snapshots. Now, we only recommend this when running on its native platform for now. Not because we don't trust ZFS on Linux, but we've not seen enough to actually trust it. So your mileage may vary. If you're actually using it, then good. We'd like to hear from you. So it's basically the same thing, but ZFS does not need to sync and does not need to, freeze the file system. You just, if you're using InnoDB flush log a TRX commit equals 1, just take the snapshot. You don't need to flush tables and flush tables with read lock. But if you're using InnoDB flush log a TRX commit equals 2 or 0, well, we recommend to still flush tables with read lock. It's fast anyway, unless, again, if you have thousands of tables actively in use. Of course, we can't let EBS snapshots pass by. The process is basically the same, but in this case, the performance difference is diminishing because once the snapshot is taken, block by block, the snapshot is actually copied to S3 and you don't have to worry about it. You just have to wait to complete. And your MySQL server goes back to business after that. GCE snapshots, or Google Cloud Engine snapshots, basically works the same like EBS snapshots. The recommended way to take snapshots based on their documentation is to also do sync and fs freeze and then unfreeze and then unlock tables as soon as you've done the snapshots. But I think if I remember correctly, in the second generations of the Google Cloud Storage volumes, you don't need to do that. You just need to take the snapshot away, and it'll take care of it for you. One claim that I have not really verified here is that there are no performance impact on storage. While I would think that I could believe that with how Google Cloud Storage is designed and how they actually mirror the blocks underlying their storage. So we have those 4 backup types that we have control on premise. Now, if you're using solutions in the cloud, if you're running MySQL databases in the cloud as a service, there are also other considerations. So primarily, if you're running against those hosted MySQL service, it's a main selling point, right? Why would you want to go into the cloud service without having a reliable backup service or reliable backup solution from them? So most of these providers, heavily advertise that they have these backup solutions, and so you'll see later on why or how they compete. These solutions can vary by provider, and you have to be really careful because, as I mentioned earlier, you can have a generation of machines that can behave differently with newer generations. So you have to make sure that you read the documentation before implementing backups with them. Although, more recent ones are always much more improved. It's mostly based on storage snapshot, of course, except MySQL Cloud Service from Oracle, which is using MySQL Enterprise Backup under the hood. Looking at the 2 most common that we've seen is AWS RDS snapshots and Google Cloud SQL. Right? It's under the hood. Both of these 2 is what I've shown with AWS EBS snapshots and GCE snapshots. But they, wrap it up for you into, one quick command line or one quick push of a button when you're using the cloud services. The one thing, or the main advantage of Google Cloud SQL here is that they offer actually point-in-time recovery. They actually ask you to enable the binary logs if you want this feature, and if you want to do point-in-time recovery, you can have, they will have in the documentation and teach you how to identify which binary log position and binary log file you want to recover into, and give you instructions on how to do that. Of course, when you're rolling out your own automated backup and restore and recovery procedures, you can definitely use that, which makes it a lot easier when you're on the service. With AWS RDS, there's a brief I/O suspension. I'm not sure if that's true on with very recent versions of, or if that's true anymore. With regards to encryption, if you're not using encryption on your RDS instances, the backups will not be encrypted on storage with RDS. But with Google Cloud SQL, it's encryption everywhere, in transit and at rest. Let's move on to monitoring and testing.
So it's widely advertised that backup and restore is incomplete if you're not monitoring and testing your backups. So as a disaster recovery plan, until you know that you can trust what's been written to disk and you've tried to restore it and everything's clear, you don't really have a backup. So backups as we identify, the processes, the tools, the considerations, are really about 50% of the work that you need to do to meet these objectives. So our recommendation, and I think, industry-wide, it's certainly poised that unless you're testing these backups, but also the processes, so making sure that they're well documented, they are the right processes for your use case, for your business constraints, and also that your team are well versed in this. So, having been woken up in the middle of the night for emergency reasons, I don't want to be fumbling around trying to work out how to decrypt an archive and bring it to the point where I can actually recover. And of course, as you continue to test, it shouldn't be a one-off thing. You should be designing and automating these things. As your data set changes over time, it grows, it shrinks, you'll be able to fine-tune your backup implementation. So maybe you're no longer going to be able to store all the backups you need on local storage, and now it's time to evolve and introduce S3 uploads or something. So what do we really need to test? We need to ensure that we're testing our full and incremental backups. So in the instance where we're using ExtraBackup, we can take a full fat backup, and then incrementals along the way, maybe a couple throughout the week in the intervals between fulls. But we need to know that they work. Once we've been able to test and restore, maybe into another environment or a dedicated restoration test box, a solution that we've implemented in a couple of places is to connect this restored machine to our replication topology. So we can verify that the data that was captured in the backup is consistent with what's on production. So we can allow replication to catch up and use PT table checksum to give us the green light that we're happy with that point in time. Testing the restore. So this is the phase of which we may need to go to our backup storage and take that data, move it somewhere where it can be inflated, decrypted, and ready to put into recovery, which is the next phase. So what do we need to get to a point in time where we're able to get customers or connections back on the instance? So from raw storage, so again, it could be an S3 bucket, pulling our archives down, decrypting, decompressing, applying any deltas, applying transaction logs. That's the journey to recovery, and then bringing recovery into place so that we're now able to continue to do business, to continue to do what our applications are meant to do.
Okay, so hello. Okay, so what we test are the actual backup results, the people involved, and the processes. We make sure that they work and we make sure that they are successful. But it does not mean that our backup systems in place are already 100% green. We need to monitor that they're actually there, and we need to monitor in the right places. The first one is there sufficient disk space available? You might have already monitoring in place for your system's disk space, but they might not coincide properly with when the actual backups are taken. Your backups can involve, storing locally or storing into remote servers. So those could fail and not be in sync with your existing monitoring systems. So look before you leap on taking your backups. Backup times are also very important. Your backup times may vary wildly, which means or could say that there are problems between those backups, right? Why would this backup have different runtimes, and why would this restore process have different runtimes? Why cannot it be consistent? How can I achieve my RTO and then my my restore point objective if the whole process is differing every time. Not only the end result, right? To get the actual insight on which parts are failing or which parts are deviating, you need to make sure you measure and monitor the processes and phases along the way. And ultimately, the backup end result, right? You need to make sure that the end result is what you need. Are you getting the full backup? Are you getting the incremental backup? Are you getting a complete set of MyDumper tables? Are you getting a complete set of encrypted MyDumper tables? So it is also very important. And again, those processes and phases along the way, you could, somewhere along the way, it could fail on encryption or in compression or in transfer or in transit to S3. The last one is the resulting backup size over time. This is also important because you need to predict where your backup sizes are going. Do you need to split? Do you need to prune? Do you need to just simply add your disk space? Otherwise, if you don't have this idea, you can end up one day, just wondering, do I need to provision a system within a day or two? Otherwise, my backups will fail. Or if I can't do that, should I reduce my retention period and, violate my restore point objective and restore time objective? So we need to make sure that we monitor these things for a successful backup implementation.
So again, into security and encryption. We've discussed some tools and highlighting them here in bullet form of the diligence we can keep with regards to security, both in connecting to an instance to garner a backup, but also it's important to understand that we have a responsibility, especially when we're working with sensitive data, HIPAA data, or other compliances where access to data should be very stringent. When we make copies of the data, certainly in the case of MyDumper, where stuff is logged out to plain text, we have maybe a race condition is the best way to describe it, where there is a point in time where some of this data is exposed or potentially exposed before the process that can come in and encrypt said data starts. So by the time we've finished writing to a file in MyDumper, it's just on the file system. It's plain text. A bad actor could find it if it's on shared storage or unprepared and be able to see the data within. So MySQL binlog, MyDumper, they have requirements to connect to an instance. So we can use built-in TLS connectivity to securely reach the instances we are backing up. And then we need to do, again, sysadmin due diligence, making sure that the locations that the files rest upon are locked down enough or locked down appropriately. We also have the option for things like file system encryption. It's certainly got its own overheads, but maybe it's necessary to get encryption at rest for those local backups that may still sit on your servers.
So another important point when considering encryption and security, aside from securing your actual backups in storage, is how it affects your process. How fast can your backups be, or how fast can your restore times be? If you are encrypting in transit, how fast is it? Or if you back up and then you transfer and you encrypt on storage asynchronously, then that might work. You can take more backups and just let the storage bake in and do its stuff if you have more IOPS there, but or more CPU on the actual storage. During the restore time, how does that affect your restore point objective? So those are the key things we take away when considering where to point the security aspect of the process. With ExtraBackup, of course, ExtraBackup connects to the MySQL server to do some metadata queries and make sure that it gets the right information on backup time. It can use, of course, SSL connections, or if SSL is not available, you can be creative with VPN connection or SSH tunneling. One good thing about ExtraBackup is the built-in encryption option. So you can encrypt on the fly and stream and in parallel, so that you don't have to worry about encrypting and piping and then transferring, right? Unless if you are not storing locally. But again, encryption can add latency, so you have to take that into account. At the end of the backup, you can, of course, do the actual final encryption, or you can use just file system encryption, as Andrew had already mentioned. With snapshots, the most common option is you can be doing the snapshot and you're storing the snapshot locally, but which is already secure. It is as secure as the source of the data, unless you're storing in NFS. But if you're storing locally on the same volume as the data, it is as secure as how you secure the actual MySQL instance you're taking the snapshot from. So, but unless you're copying the snapshot to remote, again, the security you apply in transit and at rest after that backup process is completed is also fairly important to consider.
So leads us on to, I guess, the closing question. Which one is the best and which one we recommend? In truth, as with many database questions, the answer is it depends. It largely depends on what your business needs, what the limitations are. But I think what we can conclude on is that some of all of them would be best fit. If you can manage to fit a physical backup and a logical backup and stream your bin logs off, you'll be in a fantastic place if the day comes where you have to rely on backups for disaster recovery. Thankfully, most of the time we have backups used for propagation of replicas, and that's a blessing. So sometimes by virtue, we're practiced on the tools that we select. So as we kind of reflect on slide probably 2 or 3, the pillars of a successful backup solution will essentially obey the demands of the business, utilize the technologies available to us, and again, process and procedure-wise, they are well implemented, well practiced, and well known throughout your organization. I think with that, we have about 9 minutes for any questions that anyone may have.
Yep.
I'm wondering why you don't want ever proclaim it.
Well, yeah, I definitely, and it's not an unaddressed use case, because with MyDumper you can chunk on individual objects. So you can, in fact, say that you can limit.
ExtraBackup. I know backup.
Yeah. Well, if your ExtraBackup is already, you can already parallelize per table. And if you're already doing that, it does not make sense to actually chunk tables more, unless you have a very beefy servers with a lot of I/O, or if you're transferring over the network.
Again, that's it.
Yeah.
One table which is very
Yes. Yes.
So MyDumper it can chunk tables, and it can write out to multiple files in parallel. Again, that is a use case, and then on restore, it's serialized as well. So you do have to put them back in order.
I think the specific use case here, if you have only that one big table that you want to back up, and you want to take advantage of the big IOPS that the storage might have, and including your network, then you can chunk those tables, which we do not have. And I'm not sure when we can have that on ExtraBackup yet.
For physicals, yeah, for sure. Any other questions? Sure.
Any idea if compact backups will come back in ExtraBackup 2.4?
So compact backups are the ones that are notoriously broken.
Yes.
I guess in terms of a use case, it's something we would probably like to see. I'm not sure it's something that's in the immediacy of response, the objectives from the engineering team. We can certainly, check this out, but I guess compact has always been something that is use case specific. It hasn't been something that became a blocker for us for our managed services clients. So we weren't really kind of, in pain for this. But yeah, I think it's certainly it was implemented with the best intentions. Unfortunately, not quite worked as sold. So I'd like to see in the future for sure. But unfortunately, I can't promise you anything. Okay, well, I guess we'll call it a wrap there, but Self and Jervin are around. Catch us by the booth or in the corridor somewhere. But, thank you very much for your attention and enjoy the rest of the conference.
Thank you.